Greetings everyone, DreamBooth extension of Automatic1111 API got a major update very recently. Interface has been changed and many new features are added. In this video, I am going to test all these new features on RunPod pods simultaneously. Moreover, I will show you how you can properly install and run newest DreamBooth version on the pods. All of the features of DreamBooth I am going to explain in this video applies to the Automatic1111 API PC version as well. We are going to conduct 10 different experiments on 10 different pods as displayed here to find out which features improves our training quality. My pods are ready for testing. As you can see here, I have literally spent like 5 hours yesterday to prepare these pods, solve the new problems that I have encountered. But first, let's begin with setting up a new pod, showing you how you can properly install DreamBooth extension. I am picking my new pod with having over 60 GB RAM. This is important when you are doing DreamBooth training. I am selecting Stable Diffusion 1.5 version template. I am selecting 5 GB temporary disk, 150 GB persistent volume. This is up to you. You can increase this persistent volume or temporary disk later time. However, you can't decrease persistent volume later, so be careful with that. So the things we are going to do on RunPod Stable Diffusion 1.5 applies to the 2.1 version template as well. If you don't know what is Stable Diffusion, how to use Stable Diffusion, what is Automatic1111 Web UI, how to install it on your computer, I have excellent video tutorial series as you can see right now. So in the first two videos, I am showing how you can use DreamBooth on Google Colab for free. In these two videos, I am showing how you can install and run Automatic1111 Web UI on your PC. In this video, I am explaining what is DreamBooth, how does it work. So this is a major video that you should watch for learning DreamBooth training. This is my another major video that you should watch to learn textual inversion. You can look all other videos in here. I have videos for ControlNet and I have ultimate tutorial for RunPod.io. This is really important if you don't know how to use RunPod. And this is my another very recent video about DreamBooth training on RunPods, but now today we are going to make another one because there is a major update of DreamBooth. So our new pod is started. Let's connect to Jupyter Lab. When you install a fresh RunPod, it already starts an instance of Automatic1111 Web UI. You can see the instance started here. However, this instance command line interface, the terminal, you can't see. So therefore we are going to make two things. The first thing we are going to make is preventing relauncher to continuously launching so that when we kill that initial started instance, it won't relaunch again. All we need to do is changing this forever running while loop as n smaller than 1. So after one time trying relaunching, it won't relaunch again. The second thing we need to do is open webui-user.sh file and add --share command. So with this way, we will be able to access our Automatic1111 Web UI instance from a gradual link on our browser like we are using it on our computer, no difference. Now I will restart pod for this to be effective. To restart the pod, click here and click restart pod. Pod has been restarted. We are going to install DreamBooth extension manually, not through the Web UI interface. To do that, go to the extensions folder and in here open a new launcher, new terminal from here. Copy the URL of the DreamBooth extension, type here git clone and paste the URL. It will clone the DreamBooth extension. If you already have the extension, enter inside the extension folder, open a new launcher here, type git pull command like this. It will pull the latest version for you, git pull. Once you have done this, we are going to install the requirements manually. For installing requirements, we are going to run this command, copy, paste it. So the command is pip install --upgrade --no depths --force reinstall -r requirements txt. It will install all of the requirements for DreamBooth extension. This is very convenient because it is going to also install the newest xformers version, so it will work out of box. You see, it is attempting to uninstall xformers, then it is going to install the latest version of xformers, and in the end you will see successfully installed accelerate requirement version and other things as you can see. Our we done? No, unfortunately not. So I am opening requirements.txt here. Then I will open the requirements.txt of the Automatic1111 WebUI as well. Requirements versions actually. So there are some conflicting versions of Automatic1111 WebUI and the DreamBooth. The very important one is Accelerate. You see DreamBooth is using 0.16. However, Automatic1111 currently using 0.12. Therefore, you need to change the conflicting versions of Automatic1111 WebUI requirements to the same level as the DreamBooth. To do this, you can manually check each one of the requirements in each file and compare them whether they are existing and conflicting or not. Okay, I see Git Python 3.1.27, and yes, this is a newer version in DreamBooth, so I will update the version in Automatic1111 WebUI requirements. Why I am doing that? Because when you launch WebUI, it is overriding back to the lower version of requirement, and that causes your DreamBooth to fail. Okay, I see also transformers is conflicting, so I am updating it, and it is all done. So we have changed it, Accelerate, Git Python, and the transformers version. That's it. Now we are ready to relaunch our WebUI instance. To do that, first we are going to kill the instance that is already running, which is starting when you first time run the pod with this command fuser-k, the port of the instance, which is 3000 by default, and /tcp. You see it is killed. I am seeing the message here. Then you need to run relauncher.py with python relauncher.py. It will run and we will have our fully working DreamBooth extension. Okay, after WebUI, if you get this error, this is caused by the TensorFlow installation. All you need to do is running this command. After you run this command, it will work. Okay, there is one final thing that I had to do. You see, if you get this error after all this, let me show you. The error that cannot add middleware after an application has started, you need to run one additional command, which is pip install --force fast API == 0.90.1. So unfortunately, it is installing the latest version on a new RunPod as 0.92.0. However, this is not working, so we need to downgrade it, and we are using this command to downgrade it. Additionally, if you encounter any problem while launching it, join our Discord channel. The link will be in description and also in the comments, and ask me your encountered problem. Let me show you the freshly installed DreamBooth. So you see we have the DreamBooth top with all of the necessary versions, and it is ready to work. So I'm going to start composing my first test. When composing a new model, make sure that you have selected your source checkpoint, give it a name, and then create model. Base test 0 is the same settings as previously known as the best settings. Okay, now I will show you the best settings I am using. I mean as a base settings that were best previously. So none of these are checked. Training steps per image epochs. This is up to you. I am training up 200 epochs in this experiment. I will save every 10 epochs a model checkpoint. I will save preview images every 5 epochs. Batch size and gradient accumulation steps are 1. These are working best for faces. Class batch size is 1 because I'm not going to generate classification images. Why? Because I have pre-generated classification images. These are uploaded to a Google Drive, so you will be also able to download and use them. The link will be in the description. I'm not checking gradient checkpointing. The learning rate I am using is this one, 0.50, then 2. The resolution is 512 because we are using 1.5 printed CQPT. The sanity prompt is photo of OHWX man by Tomer Hanukkah. I'm not changing the sanity sample. It will be same in all of the RunPod instances, in all of the trainings. These are not set because we don't need. I'm using optimizer 8 with ADIM. I'm not using EMA because this is increasing VRAM usage a lot. If you have 12 GB VRAM having GPU, you won't be able to run with the same settings. Mixed precision BF16, memory attention xformers. If your card is not supporting BF16, if it is an old card, then you need to select FP16. So it depends on your GPU model. Cache latents, train unit, step ratio of text encoding is 75%, offset noise is 0, freeze clip normalization layers is unchecked, clip skip is 1, ADMW weight decay is 1%, and the other settings are same, default. In the concepts, we are setting our dataset directory as training images and classification images. This is my training images dataset as usual. No same backgrounds, no same clothings, different shots of the face from different distances. I'm not using firewalls. because when teaching faces, I find that no need to use file words, file captions. So my instance prompt is ohwxman. ohwx is my rare token, man is my class token. This will be used when training images. Class prompt is photo of man. This will be used when it is training for regularization to keep the model sanity and prevent overtraining. So when you generate your classification images, you should use same prompt that you have typed here. Sample image prompt is photo of ohwx man. Okay, now this part, we are going to use 50 classification images per training instance. The classification scale 7. These matters if you generate these new classification images through the DreamBooth extension. So you should also set these values. I'm going to generate 2 samples during training. The sample seed will be -1. Okay, and these are the other settings. Okay, in saving tab, we are going to generate a CKPT file when saving during training. So we did set save every 10 epoch. So every 10 epoch, it will generate a CKPT file. Make sure that you have sufficient amount of hard drive. So this will generate 20 checkpoints and it will take roughly 100 gigabytes disk space. And in the testing tab, I am going to pick deterministic, so it should be same in all of the training experimentation. This is supposed to make your training reproducible. Save settings, hit train. And the training for first experiment, the base experiment, the test 0 is started. Now time to start other tests. Okay, when generating test 1, I am going to show you a neat trick I am using. I am first selecting test 0. These test 0 settings exist in this machine as well because I have cloned it. Load settings, then go to the create tab, type test 1, select the printed CKPT file, hit create model. Now test 1 is selected here and the settings are loaded, so they didn't change it when a new model is generated, so that I won't be need to set all of the parameters again and again. The only different parameter for test 1 is use DEIS for noise scheduler. So it is an option, a new option here. It changes the noise scheduler and I am setting deterministic. Save settings. You can also click load settings to be sure, then click train and it will start training. So test 1 has been started. Now time to go for test 2. The only different thing in test 2 is unfreeze model, and so we are going to test it. Create model with unfreeze model option. Okay, save settings, load settings, test 2 is selected. Make sure that you see, hit train and test 2 is started. Okay, test 3 is Lion Optimizer, which is a new optimizer we select in the advanced tab, which is here. Instead of optimizer 8-bit ADM, we are going to select Lion. When we use Lion Optimizer, it is suggested to use 10% of the original learning rate, so I will set it as that. So I am changing my learning rate to this one, you see, 0.60 and 2. Hit save settings and hit train. So the test 3 has been started. Okay, for the test 4, we are going to use the new feature offset noise. If you wonder what is offset noise, it is supposed to improve generating dark or light images easily. So which value of offset noise we should use? Recommended value is between 5% and 10%. So I will pick this 7%. And this setting is available in the advanced tab. In the bottom, you will see offset noise. So let's set it as 7% like this. Okay, and hit save settings, load settings, make sure that the correct model is selected, hit train and it is started. Okay, in the test 5, we are going to use freeze clip normalization layers, which is another option in the advanced tab. So I'm setting it, hit save, load settings and hit train. So the test 5 has already started. Okay, now time to do the tests that require more than 12 GB VRAM having GPUs. So the first test we are going to do is EMA plus EMA for prediction. If you have only 12 GB having GPU, unfortunately you won't be able to run this test. For this test to work, first we need to enable EMA during training. From advanced tab, use EMA. Then we need to pick use EMA for prediction, save settings, and the training has been started. Unfortunately, the graduate interface is frozen. This may happen sometimes, but still you can see the process in your terminal window, as you can see right now. My test 7 RunPod is currently do not have any GPU available. Therefore, I will run test 7 on my test 0 RunPod. So you may encounter this problem. When you encounter this problem, you can still start your RunPod, get your files, download them. However, you have to wait until a GPU gets free on this RunPod to use GPU on that RunPod. Okay, for test 7, we are going to use EMA from here, and then we are going to enable use EMA weights for inference in the saving tab, save settings, load settings, and hit train. So the test 7 is also started. Now time to do test 8. In the test 8, only difference is use EMA. So let's set it and start the training. Use EMA here, save settings, load settings, and hit train. Okay, I have encountered the configuration error. This may happen sometimes. Just reload the web UI. Refresh model list, select your model, load settings. You may want to quickly verify your settings, hit train, and now it is started, you see. Okay, for the test 9, we are not going to use xformers. To be sure that it is not used, I will disable xformers command from the command line arguments from here, web UI -user.sh file. Once you do this, you need to restart web UI, obviously. Okay, looks like test 9 pod also don't have any GPU at the moment, so I will run this test 9 on test 1 pod because this has been completed. I will add more disk space to it and use that. Okay, now time to do test 9. In the test 9, we are not going to use xformers. I have started the WebUI instance without xformers. So now in the advanced tab, I will select memory attention default, mixed precision FP16, deterministic, save settings, load settings, make sure that settings are correct, and hit train. You can also see that no module xformers proceeding without it in this instance because the xformers is removed from the command line arguments. Okay, now I noticed something else. When you use EMA plus EMA for prediction, it uses 9 GB VRAM. However, when you use EMA plus EMA weights for inference, it uses 12.5 GB VRAM, and when you use only EMA, it uses 12.5 GB VRAM. And when we don't use xformers and when we use FP16, it is using 17.4 GB VRAM, and we are not even using EMA. You see, EMA is false. In these ones, EMA is true, EMA is true, EMA is true, because this is test 6, test 7, test 8, and now we are running test 9. Okay, looks like for test 9 to run, we have to enable xformers, but we will not pick xformers in the settings because it is not working when we run it without xformers. Yeah, this is definitely an error, probably in the programming. So it is trying to use somewhere xformers even if we don't pick it. Yeah. Okay, so I am restarting the test 9. This time xformers flag is given, but I am just selecting default and FP16. So let's see if it will work this time or not. Okay, load settings, hit train. Okay, it is using 17.4 GB VRAM again. So since we didn't enable xformers, but I hope we don't get error this time. Okay, looks like error were caused when it was generating samples. Probably the error cause was it was expecting to use xformers during generating image, but it was not enabled. And you see after generating samples, the VRAM usage also dropped. This is really interesting. There is definitely some bug in the script, but it is working so far. Good. In the experiment 6, I have encountered errors 2 times. For example, the last encountered error is happened at the step 4320. So basically I am going to continue training with the remaining epochs. How many epochs I need more? I need 20 epochs because our target epoch is 200 and the model epoch is currently 180. Therefore set the epoch count as 20, save settings, load settings, and hit train, and then you can continue training if you encounter such errors during training. Okay, all tests have been completed. I have downloaded the samples of all tests. Let's take a look at the samples. This is the base test, test 0. My face becomes like me after like 480 steps. So let's take notes. Test 0. Okay, 480 steps beginning. We can say then when it loses its styling ability is, okay, I'm checking. Yeah, it's still able to keep up. Okay, after 2040, steps, and then it becomes, you see, really bad, as you can see. Okay, let's take a look at the test 1. So in the test 1, the difference is we are using DEIS Noise Scheduler. The face becomes like me after, again, 480 steps. And when does it loses its styling capability is, okay, I'm checking, I think it loses its capability same, yeah, 2040. Okay, this is test 2. In the test 2, yeah, 480 steps. Oh, I see a nice one here. Okay, and when does it loses its styling capability is, okay, I am checking that. So like 2040 steps again. So nothing different for test 2 as well, which is Unfreeze model. By the way, we will compare how well they are performing when we use a certain prompt. So do not worry about it. I have a systematic for that. I will explain. So let's check out the test 3. Okay, in the test 3, we start to see some difference than the previous ones. We can say the face starts to appear after, let's say, okay, yeah, none of them is really looking good. So maybe I will say this one, 1080 steps. And when does it loses its styling capability is, I'm checking, wow, it is really able to keep styling pretty decent if you ask me. So when does the test 3 lost its styling capability is, yeah, right after the best one, 3120 steps. Okay, so in the test 3 we were using Lion Optimizer. Looks like Lion Optimizer is, yeah, looks like better than the previous one actually. So the Lion Optimizer made the biggest difference among all other settings so far. Okay, now let's look at the test 4. In the test 4, we see that styling capability of the model is lost pretty quickly just after 600 steps, and the face also appeared pretty quickly. We can say that after 600 steps, so let's take note of them. Okay, now let's see the test 5 results. In the test 5, I see that the face appeared in the 480 steps and the styling capability is lost after 2040 steps. So not much looking like different from the first ones. In the test 5, we used freeze clip normalization layers, but there is a styled image here which looks like pretty decent. So we will see the results of this when we are doing full comparison with XY plot and a nice prompt. So I have taken note of the test 5 as well. Let's move to the test 6. Okay, in the test 6, we see that the face somewhat appeared after only 480 steps, but none of it looking good actually. So the face is looking weird than the original training dataset, unlike the others. The styling capability of the model is never lost. This is pretty significant. It is always able to stylize the model, stylize the output. You see, never lost. So this is a very significant difference than others, but the face is not looking good. So we will see how it will behave where we are doing comparison. I am wondering that as well. In the test 6, you see we are using EMA plus EMA for prediction. So this is the first test I have used EMA as an experiment, and the results are significantly different than others. Actually, for styling, I will say 4320. After that, not much styled. This is just looking as black and white. So the results is for test 6 is 400 steps first phase and 4320 steps loses styling ability. Now let's look at the test 7. In the test 7, we see that the face appeared almost as soon as 240 steps, or I will take 480. Yeah, this looks bad. Yeah, this looks better. 480 steps, and the styling capability is quickly lost actually after 840 steps. After that, I don't see the styling, and then it quickly becomes pretty overtrained. So this became overtrained pretty quickly. So the test 7 is 480 steps first phase and 840 steps loses styling ability. In the test 7, we used EMA plus EMA weights for inference. As you can see, in both cases, the model trained pretty quickly, but this one has much better faces than EMA for prediction. And the test 7, Okay, in the test 7, we see that the first phase at 360, yeah, and then the styling ability is lost after 840. Yeah, this is like the previous one, pretty much overtrained it quickly. So for test 8, 360 first phase and 840 steps loses styling ability. So in the test 8, we only used EMA weights. The phase is looking decent, but it became overtrained pretty quickly. So we will see how it will perform in the end. And for the test 9, in this test, we used the best settings of the default settings, but we didn't use xformers. And instead of xformers, we used default memory attention. So let's see how it performed. This is supposed to working better than the original because xformers is supposed to reducing your training quality. Okay, I see the first phase somewhat in 600 steps and the styling capability is kept until 1560 steps. The results are looking decent. We will see in the end how it performs. I can say that without xformers it is trained faster than with the xformers version. Okay, we have done all the comparison of the samples. Now time to do final comparison. Okay, now time to do our final tests. For this, first we are going to find a good seed. Then with this seed and the prompts we have prepared, we are going to compare every checkpoint of every trained model. Test 1, test 2, test 3, test 9, test 0. Then we will analyze these checkpoints of every test and get their best checkpoint, and we will compare all of the best checkpoints of all trained models and we will decide which one is performing best. So I am going to find my good seed on the test 0, which is our base test, and I am going to use 50 epoch of the base test. Actually, how did I decide this 50 epoch to test it to find the good seed? This is same as our previously known experiment 50 epoch, and I decided it by looking at the sample images. 50 epoch is looking like best, 1200 steps. Okay, let's find the good seed first. Okay, I think I got a decent seed to test that. I have shortened the prompt for both negative and positive prompt because very long prompt drives the image away from yourself, from your subject. So making too long prompt is not very good. In some cases, this applies for negative prompt as well. I am going to share all of the prompts and other settings used in this experiment on a gist post on my GitHub. This will be public and this will be in the description. So let me show you the images. This is the first image. These are the original training images and this is the first image. This is the second image. This is the third image. This is the fourth image. This is the fifth image. This is the sixth image. This is the seventh image. And this is the eighth image. So let's test this setup on all of the training sets, on all of the experiments, and find out the best checkpoint for each of the experiment. So for testing this, we are going to use XY plot. Open the XY plot in the below. But before doing that, verify that your seed is working as expected. You need to use the seed of the first image displayed in here, because when you generate images as batch, it starts from your seed and increase it by 1 for other images. So if you use the second image as a starting point, then the ending image will be different than this dataset. Okay, in the XY plot, we are going to use checkpoint name. A box should appear here to fill all of the checkpoints. If it is not appearing, like in my case right now, you should refresh your web UI instance, which I am going to do. Okay, after I did refresh, it appeared. Click this, select the checkpoints that you want to test. You see now it is automatically generating safetensors files instead of CKPT files. This is the safe version of CKPT. This file cannot contain any harmful applications hidden inside your model. Okay, all settings are set for test 0. I am also going to add a grid margin 20 pixel like this. Also, do not check keep -1 for seeds, otherwise you won't be able to compare same seed between different checkpoints and then hit generate. Okay, all tests have been completed. Now I will show you where you can download the generated image. It is inside outputs, inside text to image grids. Go to the latest folder, and in here you will see a PNG file which will be pretty big. For example, 72.9 megabytes. Right click, download. So this is how you can download the grid files. All grid files have been downloaded. Now we will compare them and see which one of the checkpoint is performing best. So let's begin with the test 0. Okay, in the test 0, it is starting from epoch 10, and every 10 epoch is saved. So this is epoch 10, this is epoch 20, still not my face. Epoch 30, I see my face, I am starting to see my face. Epoch 40, 50, and it goes on. 60, 70, 80, 90, 100, 110 epochs. Okay, I see a very good clear image here. The stylizing and the quality is still significantly good. 120, 130, 140. The quality is still really good. It looks like they have improved the DreamBooth extension. Okay, on 150 or even more, this is 180. You see stylizing is almost gone. It is just drawing out my image. Okay, this is 190 epochs, but the quality is still good. And this is the 200. Yes, we can see it is already becoming overtrained. So which epoch is best? It is hard to decide which epoch is looking best. It is a subjective term, of course, but from images, yeah, I am having hard time to decide which epoch is looking best. They are really all good quality, but this one is looking like the best one. So this is epoch 140. Epoch 130 is also pretty decent, so it is hard to decide, as I said, but I will say 140 epoch. Test 0, 140 epoch, looking like best. 30, 60 steps. Okay, now time to move test 1. Okay, so in the test 1, let's see. Even in the 10 epoch, there is some similarity, but not much. In the 20 epoch, there is certainly similarity of the face. In the 30 epoch, it becomes more like my face. And in 40 epoch, it is even getting better. This is 50 epoch, looking very good. 60 epoch, looking very decent. By the way, if we remember, test 1 was used DEIS Noise Scheduler. We are seeing pretty good results overall. So it is again hard to decide which one is looking best, but I can say that after 100 epochs, it becomes more like overtrained. I see that stylizing is kind of reduced or not maybe. Yeah, really hard to decide. All of them is looking pretty good. Good quality. There is no degradation in the faces. Pretty decent. Okay, so how are we going to decide which one of the epoch is best for test 1? It is really good. Actually, it only becomes overtrained in the very end, as you can see. So this is the 200 epoch, 190 epoch, 180, 170. Okay, so according to me, let's see which one is best. Really hard to decide. It is really hard to decide, but I think I will go with 3120 steps, which is 130 epoch, looking best. Okay, now we are at the test 2, which is Unfreeze model. Let's see if there is any significant difference between the base or not. Okay, I see decent images, but let's see which one is best. It has added me a good mustache actually, even though none of my pictures have mustache. Let me show you once again. So you see I have no mustache in any of them, but there's a good mustache here. Okay, so which one is best? This is the $1,000,000 question. Which one is looking best? Wow, this is really cool one. Okay, let's see. This is looking very good. The images are looking very good. I think there is an overall improvement in the DreamBooth training when compared to previous versions. Okay, this is 130 epoch, 140 epoch actually. This is 150 epoch, this is 160 epoch for test 2, 170, 180 epoch, 190 epoch. Each epoch is still looking good, producing different images, and this is 200 epoch. The results are really good. So which one should we take? Yeah, I am having hard time once again to decide because they are all looking good. So it is not like one of them is best. So what could you do in such a situation? you could do batch processing and generate images on the different epochs and pick the best ones you like. So you would use all of the epochs and you would get the best images you want. You don't have to stick one epoch. You can choose the best working epochs and generate images on all of them with XY plot. This strategy would work very well. For this video, I think I am going to take 100 epoch. Yes, I will take 100 epoch for test 2. Okay, now test 3. In the test 3, we did Lion Optimizer. This is a new optimizer that has been just added. And let's see, in the 10 epoch, not my face, 20, not my face, 30, somewhat similar, 40, still, yeah, somewhat similar, 50, somewhat, okay, 60 epoch. Stylizing is much better, you see, it is completely stylized, it is following the prompt significantly better than others, as you can see. Okay, we are almost at 100 epoch, but yeah, the pictures are really good. I think this optimizer is working better than the other for stylizing, but it is up to you to pick the which one you want. Okay, this one is looking pretty decent, so it is hard to decide. This is 100 epoch, this is 110 epoch, this is 120 epoch, this is 130 epoch, this is 140 epoch, this is 150 epoch. This optimizer is making a significant difference in your training results. So this is 160 epoch. I see some overtraining perhaps. Yes. Okay, this is 180 epoch and yeah, pretty decent. The results are pretty decent. Okay, hard to decide which one to take. This is 190 epoch. Wow. The quality is amazing. Okay, so which one should we take? This is 190 epoch. Yeah, very good image there is. And this is 200 epoch. Okay, wow, this is like taken from a movie. It looks like taken from a real movie actually. Okay, so which one should we take? And still not overtrain it, I think. So with Neve Lion Optimizer, the overtraining problem looks like in the past. I mean, it is harder to overtrain now because I can clearly see that it is much more able to follow my prompt. Why? Because in all pictures I have armors, as you can see. This is a significant difference from the others, so it is much more able to follow our prompts. In all images I see that I have armor like I have typed. So this was the prompt that I have used. Face off OHWX man wearing royal armor. You see, with Lion Optimizer it is much more able to follow and obey this prompt because I see a royal armor is worn in every image. This is not the case in other images. Of course, the face similarity is somewhat problematic, but it is following the prompt very well. This means that it is not overtrained with my subject. This is extremely good, extremely useful, and this is a new discovery for DreamBooth training. Yes, I like it. This is pretty good. So which epoch should we take? This is the $1,000,000 question. Yes, and I can't decide it. All of them is looking good. All of them is somewhat different. You see, like these pictures are from taken real movie. As you can see, this is really interesting results. Okay, which one should we take? I think I will go with 150 epoch. It looks like I was playing in a movie. They are looking really good, but all of them is really decent. So hard to decide, but for this one I will decide this. Okay, so now time to check out test 4. Okay, in the test 4 we got significantly different results even though we were using the same seed. This is really interesting. You see, even though everything was same during the training, test 4 is significantly different. Why? Because in test 4 we have used offset noise, and I can clearly see that the images generated by it has much more significant black and whites. Yes, this looks like the case. The overall images are like more black. So if you want to obtain more black or white, then you should use offset noise. You see, there is a clear difference between the black background and the white foreground. This is significant discovery. Yes, I can clearly see the lightning it has added. You see the blackness it has added. So this is another significant discovery. Yes, which image is looking best? However, the stylizing capability is not looking very well, but the images are still pretty significant. So in the 200 steps, there is overtraining. In the 200 epochs, in the 190 epochs, yeah, results are not very good, but you can clearly see the black and white differences like the article mentioned. Okay, so which epoch is best to choose? This is the 150 epoch. It is looking decent. So if you want to generate black and white images, this is really good. If you want to obtain contrast, this is really good. Okay, this is 130 epochs, 120 epoch, 110 epoch, 100 epochs. This looks pretty decent. 190 epoch, this is also looking pretty decent. So which one should we take? And 100, and this is actually, this is 90 epoch, this is 80 epoch. In the 80 epoch, the face is not very much like me, so yes, this probably requires more training. I think I will go with 100 epoch. This looks like the best one. Yeah. Okay, now we are seeing the test 5 results. In the test 5, we have tested freeze clip normalization layers. And let's see if there is any significant difference in the test 5. Let's look at them like this. When we compare all the best checkpoints, we will get a more clear idea between these minor differences. So this is 100 epoch, this is 90 epoch, this is 110 epoch, this is also looking pretty decent one, 120 epoch, 130 epoch, 140, 150, so 160. Okay, it looks like the quality is degrading after this. Which one should we take for this one? Okay, I think I will take the same as the base one so we can see if there is any difference. 140 epoch I'm going to take. Okay, now the results of EMA. There is a significant discovery in this one as well. Let me explain to you. The face is not like me, but the important thing is I think it is much more able to stylize. Let me show you what I mean. All of the images are stylized, so this methodology perhaps could be used for teaching a style. This is a worth to try, and you are learning this in this video in our channel. So please subscribe, make a comment, share, and if you be patron supporter us, I would appreciate very much. Every image is stylized. It is perfectly able to keep styling. So you see, it is never becoming like original subject. All images are stylized. Even the 200 epoch, you see, it is full stylized. The face is not like me, but it is able to follow style very well. The style is amazing. This is able to keep the style perfectly fine. The face needs to be worked on, definitely. Probably I need to modify the prompt and maybe I can get the better face, but style is amazing. It is perfectly able to keep style in every image. So this is a new discovery. I think this is worth to experiment with and test out. Okay, for test 6, I am going to use 100 epoch, actually 100, 110, 120, 130. I can't decide, but 120 epoch, yes. But for this one, we really need to test different seeds, different prompting, because the way prompts work on this one is significantly different than others. So let's pick 120 model for this one. Okay, in the test 7, let's see the results. 10 epoch, 20 epoch, 30 epoch, 40 epoch, 50 epoch, 60, still not much my face, 70 epoch, yes, I see some similarity, 80 epoch, 90 epoch, 100 epoch. I think this is also able to follow our prompts much better. 110 epoch, 120 epoch, yeah, significantly different than others. 130, 140. So if you use these new things, EMA for prediction or EMA weights for inference, then you will be need to change your prompting style than before. It is still fully stylized. You see there is no overtraining. The images are not becoming raw or subject. Even in the 200 epochs, yes, even in the 200 epochs, it is not becoming our subject. Let me show you what I mean by a comparison. So in the base model, this is the 200 epoch. You see simply my face, not much stylizing. But in this model, it is completely stylized based on our prompt, but the face is not much our face. So there is a significant difference between how you prompt when you use EMA weights for inference or when you don't use EMA weights for inference. Or the same rule applies for when you use EMA for prediction. It completely changes the output, as you can see. So for this one, which one should we take? There is not much difference between each of the epochs actually. It is almost, yeah, it is producing same. This is almost same, not the same. You see there is a difference in here. So it changes, but it changes pretty insignificantly between different epochs. I wonder that if this method needs more training than 200 epochs, perhaps it is requiring. I see somewhat similarity in this one, this epoch. Yes, there are some similarities in this one as well. I think I am going to pick the 120 epoch. Yes, so let's pick the 120 epoch for test 7. Okay, now we are seeing the test 8. In the test 8, we use EMA only and no other options. So for comparison, I think I will pick the same epoch of the base model, which is but before, let me show you each one of the epochs. So this is 200 epoch, this is 190 epoch. There is a significant difference between the base when you use EMA. So if you don't have a high VRAM having graphic card like me, there is a significant difference that we are missing perhaps. So 200 epoch, 190 epoch, 180 epoch, 170 epoch, not much changes when you use EMA. This is something that I noticed. So which epoch is looking best? By the way, this image can be fixed very easily with inpainting. Hopefully I am planning a video for that as well. So for distant shots, don't worry that you can fix them. Okay, this one is looking pretty decent. 110 epochs. This is looking pretty decent. 120 also looking pretty decent. Maybe I should pick this one. 130 is also pretty decent. So it is again hard to choose the best one. Okay, so which one should we take? Perhaps I have saved too many checkpoints with 10 epochs. That is why we are having hard time. Perhaps I should have made them 25 epochs. It would make the difference more significant between different checkpoints. Okay, I think I'm going to take 130 epoch. This looks like the best. Okay, now test 9. Let's see what difference do the xformers is making in the test 9. We didn't use xformers, default memory attention and FP16 is used. So let's see what kind of difference we have. By the way, this has significantly increased the VRAM usage, so you need 24 GB to use this. I think there is a significant difference between the base model and this one. Yeah, the results are stunning when we don't use xformers. I like them. So let's see which one is looking best. So let's start from 200 epochs. So this is 200 epoch, pretty much overtrained. You see there is no styling at all, almost. 190, 180, 170, 160, 150, 140, 130, 120, 110. Yes, 120 is also still not stylized outputting my face, but in 110 all images are stylized, and this is 100 epoch. So 110 is looking like the best one. This is 90, this is 90, this is 80, this is 70. Yeah, I think I will go with 100, 110 epoch or 100. I can't decide. Yes, I think I will go with 110 epoch for test 9. So now I will download all of these checkpoints and I will make the final grid file. Currently, I am downloading 4 of the model files by using RunPodctl. Let me show you. I am able to get 100 megabits download speed by downloading multiple files at the same time. My internet speed is 100 megabit and I am almost at full. I have started the pods with only CPU option, so they are using lesser credits of me. If you don't know how to use RunPod, I have explained everything about RunPod in this ultimate tutorial video, including how to use RunPod CTL. Currently, I am having problem to connect Jupyter Lab of this RunPod, so I have connected to web terminal, and in the web terminal this is an interface that you get. When you type dir, you will get the directory listing. So in this directory listing I am going to go models, and in here I will go stable diffusion. Okay, inside this model I am going inside cd test2, and when I dir, it will show me all of the files. I'm going to download this file, runpodctl send test2 2400 safetensors. So now file is getting downloaded. If you encounter such Jupyter error, you can also use this interface. And when you click again connect to the web terminal, it will open another terminal for you. Okay, so all files have been downloaded, and I have moved all of them into my local folder, and my local instance of WebUI is running. Now I am going to do the final test with the same prompt on all of the models. All test files are checked from the checkpoint name, test 0, 1. By the way, this is missing some, so what we need to do is click refresh here again. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All is there. The seed is set, batch size is set, CFG value is set, and now time to test. There is one thing that I want to mention. Test 7 has lesser size than the other ones because in test 7 we use EMA plus use EMA weights for inference. Inference means that when you are going to generate an image, a new image, therefore only EMA weights are saved, and it is lesser than the original weights. You see, this is 2.21 gigabytes and other ones are 3.81 gigabytes. So the final experiment has been completed. Before delving into it, please consider subscribing our channel. Support us by joining if you are able to. Join our Discord channel. You will find the link in here or in the description or the comment of the video. And if you support us on Patreon, I would appreciate that very much. Currently we have 27 patrons and they are helping me tremendously. I am hoping that you will also become our Patreon. Thank you so much. Okay, now time for final comparison. This is test 0, test 1, and let's see the results. Okay, I will slowly show all of the results. This is test 0. As you can see, pretty good, pretty decent quality. This is our base test, by the way. This is test 1. In the test 1, what difference do we have? Both of them are looking very good. Can we say one of them is better? So the test 1 seems like a little bit better than the original, and in the test 1 we used DEIS for noise scheduler. Therefore, I think this is improving the overall quality. Not very significantly, but it is increasing. Okay, in the test 2, the results are little bit more different than the test 1. You see different pictures generated. This is extremely well stylized, but not very similar to my face. So which one is better? Okay, apparently unfreezing model makes difference, but is that difference is better or not? This is the ultimate question. So I will compare it with the base test. I am copying this, opening a new page, double size. Okay, so this is test 0 and this is test 2. Which one is better, we can say? I think base model is looking a little bit better, so I can't say unfreeze model making huge difference. It is certainly making difference, but we can't say huge difference. So it is up to you to use it or not. I think both of them are decent, so it may be a little bit improving or maybe not improving, but I can't say it is harmful to enable this, so you can use it from now on. Both results are very decent. And when we do unfreeze model, it took lesser steps to get this quality. So that is another important thing to consider. Okay, this is test 3. Let's also compare test 3 to test base test. Okay, now we are seeing test 0 versus test 3. In this case, which one is better? Test 3 is more looking like from a real movie, if you ask me. So I can say that the quality of test 3 is better. The face is somewhat not like me in this test, but the quality is better. So it is up to your taste. If you prefer, you can go with test 3 configuration, which is Lion Optimizer. You may obtain better quality images in terms of reality with Lion Optimizer, but it looks like not exactly my face, so therefore it may require more fine-tuning of the prompts. But if you can do that, then you may get good results, better results than the base test for sure. Okay, now test 4. In test 4, the difference is very clear. You see the darkness and whiteness of the images are much better because, as mentioned in this article, it allows stable diffusion to generate very dark or light images easily. Therefore, you see the images have much better dark and light difference. So it is up to your taste which one you prefer, but this is significantly changing the output results. Let me show you the comparison. So this is base test versus offset noise. It is up to you to prefer which one of them you want. If you want to have much better light and dark images, then you should go with offset noise, or you can set the offset noise lower than I did, so it may not have this much significant impact, but it clearly improved the light and dark difference, you see. Okay, now test 5. In the test 5, this is the results comparison. I can't say test 5 is looking better than the base model actually. So what did we use in test 5? We used freeze clip normalization layers. I can say that it didn't improve well. The images are almost exactly same, but which one is better? For example, let's zoom in this one. Freeze normalization layers result, and this is not freezing, so let's make a better comparison. Okay, so which one is looking better? Actually, when we look at the fine details, there is a slight difference in here and in here. They are almost looking like same. So I don't know what kind of effect did these freeze normalization layers made. They are almost looking like same. There are also some subtle differences in here, you see. But I don't know. I think I would probably wouldn't use freeze clip normalization layers option because I don't see any benefit, and it might be slightly worse than the original. Not sure, it is up to you. Okay, now test 6. The difference is really huge in test 6 because it completely changed the output meanwhile we are using same seed and same prompt. Okay, in the test 6, the face is definitely not my face. It is pretty different, but it is much more stylized than the original results, as you can see. So therefore, it is up to you to use which one you want. In the test 6, we have used use EMA plus, use EMA for prediction. Therefore, the results are significantly different, but more stylized. This may work better for when we teach a style, so this is worth to test it, experiment it for styling. Okay, now we are seeing test 7 results. The results are significantly different in this one as well. They are not also very good. The faces are not very good, not like me. It is highly stylized, so therefore these may work better for teaching styles. You see, this is test 7. Use EMA plus, use EMA weights for inference. So it is up to you to test this, and if you like it more, then you can use it. But this changes how you need to prompt than before. This is for sure. Okay, this is test 8. The results are different once again. However, they are good in their way. This is more stylized. The face is mine, definitely. They are looking pretty decent as well. So when we use EMA, I think we are able to keep styling better than when we not use it. Therefore, if I had more VRAM, I think I would use EMA for sure, because it is certainly improving our success rate. When we are able to generate more stylized images, always we can modify our prompt to get what we want. So use EMA weights, definitely increasing the learning rate success, because you see, more stylizing means that our model learned with lesser overtraining. So the weights are more generalized in the contextual underlying context of the model. Therefore, use EMA weights definitely improves the success rate of the training. However, this requires more than 12 GB VRAM. Probably you need minimum 16 GB of VRAM. So this is the negative side of the EMA weights. However, you can always hire a RunPod and do your training on that. If you hire a RunPod, please register through my referral link, which you will find in the description and in the comment section. I would appreciate that very much. Okay, now this is our final comparison, test 9 versus test 0. The only difference is that in test 9 we didn't use xformers, and I can say that definitely test 9 is looking better. It is a personal opinion, of course. You may find the other one is better. However, I find that the test 9 is able to stylize better, also keeping my face. In some pictures, the face is not very similar, but it is, I think, definitely better. However, this is requiring much more VRAM, so you really need a higher VRAM having GPU for this to work. So this is also out of options for many of the people. I saw that it was using 17 GB of VRAM. Therefore, you probably need 24 GB VRAM having card for this, or you can use RunPod. So you will see the sign up link for RunPod in the description and in the comment section of this video. If you use these links, I would appreciate it very much. That is my referral having link. This is all for today. I literally spent one day just for recording video, and then I will have to spend a lot of hours to post process this video, prepare fully, manually fix its subtitles, prepare the sections of the video. So please like, share, subscribe, support us by joining, support us through Patreon. I would appreciate that very much. Hopefully see you in another awesome video. And thank you RunPod for providing me credits to run these amazing experiments.